Welcome! Today, we're diving into the world of VMware vSphere vMotion, a groundbreaking feature that has transformed virtual infrastructures since its debut in 2003. vMotion enables seamless migration of active virtual machines between physical ESXi hosts, making workload portability a reality. This capability is at the heart of hybrid cloud strategies, allowing businesses to move workloads between on-premises and public clouds with ease. Over the years, vMotion has evolved to support new technologies, but its core mission remains to provide uninterrupted service and flexibility for IT operations. Let's explore how vMotion works under the hood and why it's a true game changer in virtualization. Since its inception, vMotion has undergone significant development to keep pace with the rapidly changing IT landscape. From supporting basic live migrations to enabling complex hybrid cloud scenarios, vMotion's capabilities have expanded dramatically. Today, it's not just about moving workloads within a single data center. It's about enabling true workload mobility across diverse environments. The timeline of vMotion's evolution highlights key milestones, each bringing new features and enhanced reliability. As we look at this journey, it's clear that vMotion has been pivotal in shaping modern virtualization and cloud strategies. vMotion isn't just a single process, it comes in several flavors. The standard compute-only migration moves the active compute state of a virtual machine from one ESXi host to another. There's also storage vMotion, which handles the migration of VM storage. When combined, these are known as xVMotion. Other advanced types include long-distance vMotion and cross-vCenter vMotion, which enable migrations across data centers and vCenter instances. Each type is designed to address specific operational needs, ensuring flexibility and resilience in virtual environments. Understanding these options helps organizations choose the right migration strategy for their unique requirements. The ability to migrate virtual machines without downtime is a cornerstone of modern IT operations. vMotion empowers administrators to perform maintenance, balance workloads, and respond to changing business needs, all without disrupting users. This seamless migration capability enhances system availability, supports disaster recovery, and enables dynamic resource optimization. In today's hybrid cloud world, vMotion's role is even more critical, providing the agility needed to move workloads between private and public clouds. Its impact on operational efficiency and business continuity cannot be overstated. When you start a vMotion migration, the process begins with the vCenter server executing a long-running migration task. The first step is a compatibility check. Can the destination host run the virtual machine? This involves evaluating hardware, software, and network constraints. Once compatibility is confirmed, the vCenter server prepares a migration specification, detailing the VM, its configuration, source and destination hosts, and network information. This spec is shared with both ESXi hosts, ensuring all necessary details are in place before the migration proceeds. This careful orchestration sets the stage for a smooth and reliable migration. The migration specification is a critical document in the vMotion process. It includes information about the virtual machine being migrated, its hardware and configuration, the source and destination ESXi hosts, and the vMotion network details. This specification ensures that both hosts are fully aware of what's being migrated and how. The vCenter server communicates with the ESXi hosts using the Virtual Provisioning X Daemon (VPXD), which interacts with the Virtual Provisioning X Agent (VPXA) on each host. This communication ensures that the migration process is coordinated and that all necessary resources are reserved. Once the migration specification is ready, the vCenter server uses VPXD to communicate with VPXA on the ESXi hosts. VPXA listens for migration instructions and passes them to the VMX process via the hosted daemon. The hosted daemon manages host-specific information and ensures that the virtual machine's configuration remains unchanged during migration. This layered communication structure is designed for reliability and security, making sure that every step of the migration is carefully managed. By maintaining strict control over the process, vMotion minimizes the risk of errors and ensures a seamless experience. The Virtual Machine Monitor, VMM, and Virtual Machine Extension, VMX processes play key roles in vMotion. VMM manages the virtual machine's memory and handles critical I/O requests, while VMX is responsible for non-critical device I/O during migration. VMM operates on the source ESXi host, as that's where the VM's active memory resides. VMX, running within the VM kernel, ensures that device interactions continue smoothly. This division of labor allows vMotion to efficiently transfer the VM state while maintaining performance and minimizing disruption. Before the migration can begin, the VM kernel migrate module on the source ESXi host opens sockets on the vMotion-enabled network. This step establishes a dedicated communication channel between the source and destination hosts, ensuring that memory and state data can be transferred quickly and securely. The vMotion network is optimized for high throughput and low latency, which is essential for minimizing migration time and reducing the impact on running workloads. Proper network configuration is crucial for successful vMotion operations. With communication paths established, the migration enters the prepare phase. Here, the destination ESXi host pre-allocates compute resources for the incoming virtual machine. The VM is created on the destination host, but it remains masked, hidden from users and workloads until the migration is complete. All configuration details are already known thanks to the migration specification. This phase ensures that the destination host is fully ready to receive the VM, reducing the risk of resource contention or migration failure. Next comes the pre-copy phase, where the virtual machine's memory is transferred from the source to the destination ESXi host. This process involves tracing all memory pages on the source host to identify which ones are being modified. These are known as dirty pages. The goal is to copy as much memory as possible while tracking changes, so that the final switchover can happen quickly with minimal downtime. This phase is critical for ensuring a smooth and efficient migration. During the pre-copy phase, the VM's virtual CPUs are briefly stunned to install page tracers. These tracers monitor which memory pages are being written to during migration. The VM kernel migration module instructs VMM to start page tracing, as VMM owns the memory page table state. This step is essential for tracking changes and ensuring that all modified memory pages are eventually copied to the destination host. The process is designed to be as non-intrusive as possible, minimizing impact on the running workload. Page tracing enables an iterative memory pre-copy process. The first iteration copies the entire memory of the virtual machine. Subsequent iterations focus on copying only the dirty pages, those that were modified during the previous transfer. For example, if a VM with 24 GB of memory dirties 8 GB during the first copy, only those 8 GB are recopied in the next round. This cycle continues, with each iteration copying fewer and fewer pages until all memory is synchronized between the source and destination hosts. This approach minimizes downtime and ensures data consistency. Let's walk through a practical example of iterative memory pre-copy. Imagine migrating a VM with 24 GB of memory. In phase -1, the full 24 GB is copied, but 8 GB are dirtied during the process. In phase 0, those 8 GB are recopied, but 3 GB get dirtied again. Phase 1 copies the 3 GB with 1 GB dirtied. Finally, phase 2 copies the last 1 GB. This step-by-step approach ensures that, by the end, all memory pages on the destination host are up to date. The process continues until the remaining dirty pages can be copied in less than 500 milliseconds, ensuring a fast switchover. After each iteration, the system checks whether all memory changes dirty pages have been copied to the destination host. The goal is to reach a point where the remaining dirty pages can be transferred in under 500 milliseconds. This check uses metrics like the migration transmit rate, dirty page rate, and the number of pages left to copy. If the criteria aren't met, another iteration begins. This careful monitoring ensures that the migration can complete quickly and without data loss, keeping the virtual machine's state fully synchronized. Sometimes the dirty page rate, the speed at which memory pages are modified, can exceed the migration transmit rate. When this happens, it's impossible to reach convergence through normal iterations. To address this, vSphere introduced stun during page send SDPS. SDPS temporarily pauses the VM's execution for microseconds, reducing the rate at which memory pages are dirtied. This fine-grained control allows the migration to catch up and ensures that the process can complete successfully, even under heavy workloads. Stun during page send SDPS is a clever solution to the dirty page problem. When the dirty page rate is too high, SDPS instructs the VM kernel to briefly pause the VM's execution, giving the migration process a chance to catch up. These pauses are extremely short, measured in microseconds, so the impact on workload performance is minimal. By using SDPS, vMotion can achieve memory pre-copy convergence even in demanding environments, ensuring that migrations complete smoothly and efficiently. As the iterative pre-copy process nears completion, the number of dirty pages drops to a minimum. The system continuously checks if the remaining pages can be transferred within the target window, typically less than 500 milliseconds. Once this condition is met, the migration is ready to move to the switchover phase. This careful preparation ensures that the final transition is as fast and seamless as possible, minimizing downtime for the virtual machine. With all memory pages synchronized, the switchover phase begins. VMM sends a remote procedure call RPC to VMX, instructing it to suspend the source virtual machine. This triggers the checkpoint phase where the VM state is captured and sent to the destination ESXi host. The destination VM is then demasked and powered on, but instead of booting from scratch, it resumes from the migrated memory state. This entire process typically takes just 100 to 200 milliseconds, ensuring a nearly seamless transition for users. During the checkpoint phase, the source VM is suspended and its state, including CPU, memory, and device information, is packaged and sent to the destination host. The destination VM is then restored using this checkpoint data, allowing it to resume operation exactly where it left off. This approach ensures that no data is lost and that the VM state is fully preserved. The checkpoint phase is a critical step in achieving a seamless live migration with minimal disruption. Once the checkpoint data arrives at the destination ESXi host, the VM is demasked and its state is restored. The VM resumes operation from the exact point it was suspended, with all memory pages and device states intact. Users experience little to no interruption, as the entire switchover typically takes less than 200 milliseconds. This rapid restoration is a testament to the efficiency and reliability of the vMotion process. The duration of the switchover phase depends on several factors, including the hardware of the ESXi hosts and the workload running on the VM. Faster CPUs, more memory bandwidth, and optimized network configurations can all reduce switchover time. Dynamic workloads that modify memory rapidly may increase the time needed for the final transfer. Understanding these factors helps administrators optimize their environments for faster and more reliable migrations. With the switchover complete, the virtual machine is now fully operational on the destination ESXi host. Users and applications continue running without noticing the migration. The source host releases resources and the destination host takes over management of the VM. This seamless transition is what makes vMotion such a powerful tool for IT administrators, enabling maintenance, scaling, and disaster recovery without downtime. Beyond standard compute-only migrations, vMotion supports advanced types like long-distance vMotion and cross-vCenter vMotion. Long-distance vMotion enables migrations across geographically separated data centers, while cross-vCenter vMotion allows VMs to move between different vCenter server instances. These capabilities are essential for large enterprises and hybrid cloud deployments, providing unmatched flexibility and resilience. Storage vMotion is another powerful feature, allowing the migration of a VM storage without downtime. When combined with compute vMotion, the process is called vMotion, enabling both compute and storage to move simultaneously. This flexibility is invaluable for balancing storage loads, performing maintenance, or migrating to new storage platforms, all while keeping applications online. Enhanced vMotion compatibility (EVC) is a feature that ensures CPU compatibility across different ESXi hosts. By masking certain CPU features, EVC allows VMs to migrate seamlessly between hosts with different processor generations. This is especially useful in environments with mixed hardware, reducing compatibility issues and simplifying migrations. VMware Hybrid Cloud Extension (HCX) extends vMotion's capabilities to hybrid cloud environments. HCX enables seamless migration of workloads between on-premises data centers and public clouds, supporting true hybrid cloud strategies. With HCX, organizations can move VMs across different platforms, regions, and even cloud providers, all while maintaining service continuity. One of vMotion's greatest strengths is its contribution to business continuity. By enabling live migrations, vMotion allows its teams to perform hardware maintenance, upgrades, and load balancing without interrupting services. This reduces downtime, minimizes risk, and ensures that critical applications remain available even during infrastructure changes. To get the most out of vMotion, it's important to optimize your environment. Use high-speed networks such as 100 GB ENIX to maximize migration throughput. Ensure that ESXi hosts have sufficient CPU and memory resources, and configure the vMotion network for low latency. Regularly monitor migration performance and adjust settings as needed to achieve line rate performance and minimize migration times. Even with careful planning, issues can arise during vMotion migrations. Common problems include network misconfigurations, insufficient resources, or compatibility mismatches. To troubleshoot, review vMotion log files and look for specific error entries. VMware provides detailed documentation and tools to help administrators diagnose and resolve migration issues quickly, ensuring smooth and reliable operations. Security is a top priority in vMotion operations. The vMotion network should be isolated from other traffic to prevent unauthorized access. VMware supports encryption for vMotion traffic, ensuring that data remains protected during migration. Administrators should follow best practices for network segmentation and access control to safeguard sensitive information. In hybrid cloud environments, vMotion enables seamless workload mobility between on-premises and public cloud resources. This flexibility allows organizations to scale dynamically, optimize costs, and respond to changing business needs. By integrating with solutions like ESXi, vMotion extends its reach beyond traditional data centers, supporting modern cloud strategies. vMotion plays a vital role in disaster recovery strategies. By allowing live migrations, it enables organizations to move workloads away from at-risk infrastructure quickly and without downtime. Combined with replication and backup solutions, vMotion helps ensure that critical applications remain available even in the face of hardware failures or site outages. Traditionally, hardware maintenance required planned downtime and service interruptions. With vMotion, administrators can migrate VMs off hosts scheduled for maintenance, perform the necessary work, and then return workloads, all without impacting users. This capability streamlines maintenance processes and improves overall system uptime. Load balancing is another key benefit of vMotion. By moving VMs between hosts, administrators can distribute workloads evenly, prevent resource bottlenecks, and optimize performance. Automated tools can monitor resource usage and trigger migrations as needed, ensuring that no single host becomes overloaded. To ensure successful vMotion operations, follow best practices such as isolating the vMotion network, using high-speed NICs, and keeping ESXi hosts updated. Regularly test migrations to identify potential issues before they impact production workloads. Document your environment and maintain clear procedures for troubleshooting and recovery. Monitoring is essential for maintaining optimal vMotion performance. Use VMware's built-in tools to track migration times, network throughput, and resource utilization. Set alerts for unusual activity or failed migrations, and review logs regularly to identify trends or recurring issues. Proactive monitoring helps ensure that vMotion continues to deliver seamless migrations. As organizations grow, vMotion supports scaling by enabling the addition of new hosts and resources without downtime. VMs can be migrated to new hardware seamlessly, allowing for capacity expansion, hardware refreshes, or cloud integration. This scalability is a key reason why vMotion remains a foundational technology in modern data centers. Automation tools can enhance vMotion by triggering migrations based on predefined policies or real-time analytics. This enables dynamic resource optimization, rapid response to changing workloads, and consistent application performance. Integrating vMotion with automation platforms streamlines operations and reduces the risk of human error. In multi-cloud environments, vMotion enables organizations to move workloads between different cloud providers and on-premises data centers. This flexibility supports disaster recovery, cost optimization, and regulatory compliance. By leveraging vMotion, businesses can create truly agile and resilient IT infrastructures. VMware Cloud Foundation (VCF) integrates vMotion as a core component, enabling unified management of compute, storage, and network resources across private and public clouds. With VCF, organizations can automate vMotion operations, streamline hybrid cloud deployments, and ensure consistent performance and security across environments. To deepen your understanding of vMotion, explore VMware's official documentation, attend training sessions, and participate in community forums. Resources like the How to Get the Most Out of vSphere vMotion session at VMworld offer valuable insights and best practices. Staying informed helps you leverage vMotion's full potential in your environment. vMotion has fundamentally changed the way IT organizations manage virtualized environments. Its ability to provide live migrations, support hybrid and multi-cloud strategies, and enhance business continuity makes it an indispensable tool. As virtualization continues to evolve, vMotion remains at the forefront, driving innovation and enabling new possibilities. Looking ahead, vMotion will continue to evolve alongside advances in virtualization, networking, and cloud computing. Expect to see even faster migrations, greater scalability, and deeper integration with automation and AI-driven management tools. As organizations embrace digital transformation, vMotion will remain a key enabler of agile, resilient, and efficient IT operations. In summary, VMware vSphere vMotion is a cornerstone of modern virtualization, enabling live migrations, supporting hybrid and multi-cloud strategies, and ensuring business continuity. By understanding its inner workings and following best practices, organizations can maximize the benefits of vMotion and build agile, resilient IT infrastructures. Thank you for joining us on this deep dive into vMotion. Stay tuned for more insights on virtualization and cloud technologies.